नहीं हम अभी because what I covered earlier was something which I covered in the last lecture. This is perhaps the most exciting part of AI, which I really liked, because it's actual you are doing some image processing, signal processing, and that is being used to devise neural networks. So that's something very interesting. And somebody thought about that, why to have the entire image, every pixel as an input. Okay? Somebody thought about it because it becomes very complex, that if every pixel is an input and every pixel is to multiplied with a weight, it becomes very. So all you are doing is you are extracting features. Okay, the whole purpose of this exercise is that you need to extract features. For example, if in an image you are finding out there's an X in it or not. Okay, so X in it has one is this diagonal line, 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 and one is this cross. So there are 5 features, 1, 2, 3, 4 and 5. So if I know that this is what I am searching, and I design a filter which can extract, one filter extract this line, another filter extract this line, another filter extract this line, if it is there, if it is there, if it is there, if everything is there, it says there is an X in it. Okay? So you have the specialized filter to primarily detect part 1, part 2, part 3, part 4 and part 5. Actually this one and this one is same, and this one and this one is same. So one filter can detect this and this, and one filter can detect this and this, and one filter can detect this. And if you do this, then you say yes, the neural network can be trained to say it is an X. So these are the filters. Filters are something which is we also call a mask or a kernel, usually very small, 3 by 3 matrix. Okay, so this is a 3 by 3 matrix which says 1, 1, 1, minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. It will detect if there is this pattern in an image or not. Then the other one is 1, 1, 1. It will detect if there is this pattern in the image or not. And the third one is, oh sorry, this is 1, 1. This is going to check the cross, and this is going to check this pattern. So you put it on the image and you keep moving it, moving it, moving it. If it matches the pattern, if it matches with the pattern, it will give the maximum output. For example, this, if you place it here, so 1 multiplied by 1, 1, 1, 1, and minus 1 multiplied by minus, 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 so it will make this plus, so it will make all ones. And all ones is equal to 9. So you get 9, you say, wow, this pattern is there. Okay, if something is 9, yes, this pattern is there. If you put it anywhere else, it is going to give a very small value. Okay, similarly, so this, similarly this one, if you match it here, match it here, match it here. So you perform convolution, and convolution is, I have this animation. Yeah, so you have this mask which is 1, 0, 1. So you see this mask 1, 0, 1, 0, 1, 0. So this is just another mask, just telling you how we do it. We place it in the corner and we multiply every element of the image and every element of the mask and add all of them together. Then we move, then we move, then we move and create another image. So if those patterns are there, we are going to get a 9 here, 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 and then smaller values at rest of the location for the previous image. If X is there, so you are going to see 999 and smaller values. So this is called the convolution. Okay, convolution is where you have a mask and you multiply. So this is the mask, and you multiply them with. So instead of making every pixel as an input, we don't change the shape of the image. We keep the shape intact. And so for example, it's a colored image, 32 by 32, and 3 is the color RGB. So we preserve the spatial structure. We are not going to change the image. We keep the image as is and bring a filter, a mask, which is maybe 5 by 5 by 3, maybe 3 by 3 by 3. 3 is for, one is for R, the other one is for G, the other one is for B. And we place it here first, then we move it another pixel, then we move it another pixel, then we move it another pixel, and every time, every value of this gets multiplied with the value of the image. So 5 by 5 is 25 values. Add them, you get one value. You generate a new image. Okay, so this is almost the same where you have these weights, but these weights are same and they are just moving on the image. This is your image pixel, and you may want to add a bias in this as well. Okay, so here is yet another. So this is the kernel filter. This is part of the image. Multiply every pixel 1 with 1, 0 with 2, 3 with 1, 0 with 4, 1 with. So every pixel, add them up together, write it here. So this will generate a new image. Okay, for example, here is an example where you put this mask on an image and then keep moving algorithmically, and you basically cover this whole thing and it will generate a new image for you. Okay, it will generate a new image for you, and this new image is basically, for example, if you have this image and you have a mass 1, 1, 1, 1, 1, 5 by 5, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4. This is the mass, 5 by 5 boxcar and 1 over 9. So whatever value you get divided by 9 to average. So it obviously you are just taking average. So every 25 pixels you are adding, dividing by 9. Here moving, adding 25 pixel, dividing by 9. So it will blur your image. Okay, this is an effect that you are creating. So these masks are used in image processing to create special effects. They are in your cameras as well now. Once you take a picture, it'll say sharpen it, put more light in it, put this in it. So basically these are the masks that are doing those things. These are the Gaussian mask. It is also doing the average, but it is where the window is placed, it is giving that pixel more value, and as you move away, it is giving them less value. So still it basically do the so it's now averaging, but it is averaging by weighted average, and this is the edge are still sharp, and you get an image here. It is blurring, but still keeping the intact. So there is another mask which does the edge detection. So here is the mask which does the vertical edges and horizontal edges are like this in the image. So you see this mask placed on this image will make this image look like this. Another mask placed on this image will make this image look like this. So it is more pronounced, and here it is another mask. So similarly, this is an enhancement mask. As you can see, it has enhanced the edges. So the magic is in these numbers which can transform an image. Okay, here is again, this is Gaussian, blur. Now this mask, if you place on an image, it will change the image to just edges. Okay, so this is called the differentiation mask. It is 1, 0, -1. How you come up with this? So this may be the work of somebody's PhD, that you have a mask which can detect the edges, and there may be some math behind it. But I want to be a dumb person. I want my neural network to learn these masks, to find out features which can be used to do the classification. So I don't want to use, that this is Gaussian or what. I don't even care. I want the mask to be trained by the humongous amount of data. And this is what I want, the features I want, which can help me to do the classification. Okay, but this is important that these masks have been in use in image processing for ages. Okay, for ages, and people have been using them to do the edge detection, blurring, sharpening, and all of this. So this is the kernels, Laplacian, Sobel, Canny. You don't want to get into how the Canny operator was to give you these masks, so very, very complex math. So end of the day, it just gives you these numbers. And you even don't want to use these numbers. You know that a mask on an image can extract some features. That's all you know. A mask, if you place on an image, you keep moving the mask, it can extract some features which can be used for classification. It can filter out things. For example, here it has filtered out all the details, only the eyes and nose and lips, and so they may be good features for your classification algorithm. Okay, So is here, as you can see, this is Laplacian operator, this is Laplacian operator, and it is just doing this. This is Canny operator is doing this, maybe extracting feature. Otherwise, extracting these features is obviously very, very difficult. So it extracts these features, and these features may help you to do the classification. Okay? This is the Canny operator. And so this is all a convolutional neural network does, that it has a color image, and to a color image, it has three masks: red, green, and blue. And these are three parts of the color image: red, green, and blue. This is an image. These are the masks or filters. This is the convolution operation. You see this mask keeps thing, it is moving. Move here, move here, move here, move here, move here. And every time it multiplies, every number here gets multiplied, every pixel value, add them up together, get this value. So this is for the red, this is for the green, this is for the blue, and then add these three numbers to create a new image. So this is how you are extracting features. Just three filters, RGB, apply on the image, moving, 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 moving. And from where you get these numbers, this is through training. So you train the network to come up with these numbers. And if you download a trained model, what it gives you these filters. A trained model has all these filters. And how many of these filters are there? Hundreds of these filters are there. Okay. So this is how it works. Because once you are keeping a mask here, okay, and then you move one pixel, so you are going to reduce the size of the image, 28 by 28. Sometimes you zero pad it on both the sides, all the four sides, so that your image size remains the same. But important is this 32 by 32 by 3 with three filters, 5 by 5 by 3 is going to generate one image, which is 28, 28, one image. Now what you do is you have another filter which is also 5 by 5 by 3. So you are going to get two images. Now you have two filters. One filter, then you apply another filter. This filter was also 5 by 5 by 3. This filter is also about 5 by 5 by 3. So you get two images. How many you are going to have? That's what again people are just trying to understand. For example, here you have used 6. There may be 128. There may be 512 filters. And every filter is extracting some interesting features from the image. Okay? You don't know what those features are. You just let the data to make the network learn all these filters or the mask. But you generate these 6 images, okay, and then you pass every pixel through this nonlinearity because you want your nonlinearity also to be there. So every pixel is passed through this nonlinearity. It may be rectifier nonlinearity, rectifier linear function which will just make the negative value 0 and will keep the positive value as is, or maybe sigmoidal nonlinearity. Okay, so this is what it is, that you have a colored image, you convert it into 5 images by having 5 filters operating on this. Okay, 5 filters operating on this, and then you go to another set of 10 filters, 5 by 5 by 6, because now there were RGB and here there were 6 images. 6 images. For every image you got to have another filter. So you have 5 by 5 by 6 filter and 10 of these. So how many images you are going to create? 10 images. Okay, 10 images. Here you have 6 5 by 5 by 3 filters to create 6 images. Here you have 10 5 by 5 by 6 images to create 10, and everything is passed through this ReLU. And sometimes once you are moving, you take a stride, like you leave one pixel, so leave one pixel. So what will it do? It will reduce the size of the image. If you are jumping, it will reduce the size of the image. Okay, so for example, if you are taking a stride, your image is 224 by 224 and 64 of these. and you are doing pulling or taking a stride, so you will make it into half because you skip 1 pixel, go, skip 1 pixel, go. And so this is what, and sometimes you do max pulling. Max pulling is every 4 pixels you just have 1 pixel. You want to reduce the size. Why you want to reduce the size? To make smaller image, same mask. So now first it will take low level features. Once your image is small, it will take medium level features. One image is even smaller, it will take the high level features. Okay. So systematically using almost the same set of filters or maybe different. So out of these 1, 1, 5, 6, 6 is maximum, so you write 6. Now these 4 pixels in green, 2, 4, 7, 8, 8 is maximum, so you replace 8. 3, 2, 1, 2, 3 is maximum, you replace 3. And here 4 maximum 4. So you reduce this size by half. So it is 4 by 4 is reduced into 2 by 2 image. So this is what a convolutional neural network would look like. There is an image, then you have a set of images, then you have another set of images, then you have another set of images, then you have another set of images, and, and finally you have the features. And features you pass it through a classification layer. So for example here, you have an image, you have 4 images made first part, then you do the pooling layer, so you're reducing the size to half. Then you have convolutional layer, again number of images. Then you have pooling layer, again reducing the size. And then you flatten this to have a normal neural network, as if you have fed features into the neural network, then you have fully connected network. You train these weights to get whether it is a bulk or a container or a passenger or a sailing boat. Okay, so almost the same. So images, set of filters, these are from our already trained model. If there is an already trained model, so you get the filters. If you are training, you got to train these weights as well. Okay, these all are going to be variables. And you have all these images, then all these images. If you look at these images, you will be amazed because they are just extracting some features from the image, and you are just extracting, and finally the last layer has your feature layer. So say you flattening, these are your features, and then you have just a deep neural network or just a simple neural network to do the classification of this. These are the images. If you can see, this is an image, this is an image, this is an image. Yeah, this is the first time you are creating all these images and you are trying to detect there is a dog in here. This is the second set of images, max pooling, and then you do the max pooling. Now your image size is reduced to half, and then you are doing again convolution and again doing max pooling, image size is reduced to half. Again you are doing convolution and max pooling, again reduced to half, and ultimately it becomes a feature. So this is features which you cannot understand really, but it has somehow automatically extracted all the features which will help you to do the good classification. Okay, so this is what the CNN is all about, that convolutions, pulling, reducing the size, convolution, pulling, fully connected layer, softmax, and here are the classes that you're going to.
This will keep the reference for model itself. Keep the reference of image model itself.
Keep the reference of
image.
Yes.
By reducing it.
Yes, it keep the reference of the image. By reducing it, it is, look, this is what it is doing. Once you do on the original image, the 5 by 5 mask, it is going to extract low level features, which are edges, dark spots. Once you reduce the size into half, okay, now it is reduced into half, mask remains 5 by 5. So because mask is still 5 by 5, so it is going to get you the mid-level feature, which is nose and eyes and stuff. Now further reducing the size, the mask is same, the size is reduced, a very small image. Now it is going to give you part of the face. Okay, so you have these features, then you have these features, then you have these features, and all these features will help you to do the classification. Okay, so this is what it is.
For example, in case of recognition, if we will give a low level image, still it can
Yes.
be recognized.
Yes, it can still, if you have trained your network, it means that somewhere here you put a low level image, maybe it may be, yeah. But it is using all the features coming from here, so it is not throwing anything.
Okay.
Yeah, it is, for example, you have extracted the low level feature here. Once you do max pulling, those features have come here as well. Okay. Then you do another, those features have come here as well. So once you are moving down, you are collecting low level, middle level, and high level feature. And once you put it here, which is you flatten the air, so these are the features. So this is your feature vector. And this is just a normal classifier. You can use any classifier as a matter of fact. Once you have features, you can use any. So this is a fully connected layer. There are weights, you train them. It make the class, and you can have the classifier doing the classification. So here is, you can see the classification, and usually it adjusts the weights using back propagation cross entropy laws that we learned earlier. So all the weights are basically done like this. So this is also another image which shows low level features. This is after putting it through this ReLU, then again convolution, low level pulling, low level hote, it is just here where it will just say it is a car. Okay. And what has made it possible? Just humongous amount of data, enormous amount of resources, and the software tool which are free of cost like TensorFlow. So you have this available, you have this available, you have this available, you have all the models available. So honestly, AI is just becoming a commodity, because just take a model and just use it. So if you have good computational resources, so for example, I asked it to generate code for a simple convolutional networks and trained it on a data set. So I asked this to do this. Look, so what it has done is first TensorFlow. So we need to understand TensorFlow, and in TensorFlow it is using Keras, and in Keras it has a data set which is already there. It has a model. So it says as model sequential, and sequential is that you are going to concatenate this, and it has layers: convolutional layer, max pooling layer, flatten layer, dense layer. So these are the layers we have studied. Like there is convolution, then there is reduction in size of the image, then again convolution, then again reduction, then again convolution, then again reduction, and finally you flatten these everything, and here is the network. So now you have this data set which is MNIST data set. You load the data set and you split it into training and testing. Okay, it is. जी मैसेज आ रहा है कि माइक्रोफोन ओए ये किसी ने भी किया है नहीं माइक चल रहा है आपको आवाज आ रही है मेरी
यस सर आवाज आ रही है
अच्छा ठीक है गुड ठीक है जी ठीक है अच्छा सो यू स्प्लिट दिस डेटा इनटू ट्रेनिंग एंड टेस्ट out of this. Okay, so then you reshape the image, because this is also I told you, like if your model takes 28 by 28 image, so you got to reshape it. So because you cannot just put a larger or smaller image, so you put it in this form, and then you are also making it floating point, because you want your pixel value to go from 0 to 1, not from 0 to 255. So you do the same with the training data and the test data. Okay, and so here is your training data and here is your output. So these are your output, actual output and training output and the test output. Now here you are, model is sequential, means you are going to just add layers. So first layer is convolutional 2D layer. Okay, here kernel is 3 by 3. Then your max pooling layer, and you are max pooling means you take maximum value 2 by 2. So out of 4, you are going to select one value. Then you again put a convolutional layer. Okay, and here there were 32 of them, here 64 of these filters, and here you have kernel size 3 by 3. Okay, and activation is ReLU. Okay, and here again you put a max pooling layer, and now you flatten the, and then after flattening it you make it a dense 128. So 128 basically connecting. So 128 nodes, then 120 nodes going into the 10 nodes. These are the output, final output, which is through the softmax. Okay, so you are using categorical cross entropy for the training, and for the weight adjustment you are using ADAM, which was the adaptive algorithm, momentum based estimator, And the metric is accuracy, that you are checking how good an accuracy you have, because now you are going to train this network. Okay, here is the training the model. So you have training data, your batch size is 128, epoch 5, you are going to run 5 of these, and here is the validation data, so test. So you basically start running it. Here is you are evaluating model, so it runs, and it says it has an accuracy of 98.99. Okay, which is very good. So,
what about, for example, on a
human face, yes.
there is side pose, for example.
But if in your data you have lot of side poses, so it will able to detect. Yes, it will able to detect. The CNN will able to detect, because this is a very simple example. Let me show you, because I have generated this code and then I changed it a little as well. So here is this data. So this data has images of numbers, because it is 28 by 28 by 1. Okay, so not very high resolution, 28 pixel by 28 pixel by 1. So as you can see, this is 5, but it also look like 3. So you don't know whether it is 5 or 3. Okay, it is 0, it is 4, it is 1, it is 9, it is 2, 1, 3, 1, 4. So these are some of the images. I asked it to plot for me some of the images. Okay, so it has just done that. Okay, so these are the layer names: convolution, max pool, convolution, max pool layers. Okay, this is fine, and we understand all of this, and we will.
Increase the number of layers also?
Yes, you can increase the number of layers. You can change the kernel size. I did that. I changed the kernel size. It actually improved. The accuracy improved. So you can just make, perhaps this is what we will do in our assignment as well, adding more layers to see that.
हमने हम लोगों ने पॉइंट किया था जिसमें इमेज से ऑब्जेक्ट को आइडेंटिफाई करना। अब मिसाल पर देश से बैनर है और उसमें दरख्त की जो कैनोपी है वो शेप में ऐसा बना हुआ है जैसे वो लगता है कि डिश एंटीना टाइप।
सही है।
वो उसको वही कह रहा है कि ये
डिश एंटीना
तो ऐसा नहीं है। तो इसकी ये क्या विजन आपके ख्याल से ये तो यहाँ पर ये
इसलिए कि आपने बहुत ज़्यादा डेटा पे ट्रेन नहीं कराया उसे अभी।
जी डेटा इतना था नहीं।
So you got to create lot of data and train it. It will definitely will figure out कि ये canopy है। ये हो नहीं सकता कि वो कहे नहीं ये जो है ना डिश है। So यही है कि yeah, maybe through generative AI you generate more data images. But important is कि आपको डेटा इसके लिए होना बहुत ज़्यादा ज़रूरी है। humongous amount of data because वो हर तरह का, जिस तरह आप देखें ना, अगर आपने इसको ट्रेन नहीं किया तो इसने तो इसको 3 पढ़ देना है। ओके, बट अगर इस तरह के बहुत सारे, और एंड देन यू हैव टू से नो दिस इज नॉट 3, दिस इज 5. So if you have like lot of these handwritten characters, it will do the best. ठीक है, it will do the best. So ये इसने prediction की है, 8 is 8, 6 is 6, 1 is 1, 0 is 0, 7 is 7, 0 is 0, 3 is 3, 0 is 0, 0 is 0, 7 is 7. This is done almost 100% on the samples it took, and these are some of the layers. नहीं, इसने ट्रेन किया सारा। ये तो पूरा हमने पूरा नेटवर्क बिल्ड किया। ये वाला जो नेटवर्क है हमने इसको ये ट्रेनिंग की है इसकी, और ट्रेनिंग में वी यूज कैटेगोरिकल क्रॉस एंट्रोपी एंड वी हैव फेड इनटू दिस टेस्ट डेटा एंड ट्रेनिंग डेटा। ठीक है, सो द गुड थिंग इज कि ये इज जस्ट अमेजिंग, लाइक द टेंसर फ्लो एंड गिव्स यू द पावर, just call this function, it will go and just train it and it'll come back that it has trained and it'll give you the accuracy, that how accurate the training is. So आपने क्या किया, यहाँ पे नेटवर्क बनाया पूरा sequential, and as you were saying you put more layers, यहाँ पे डालते जाएं आप layers, ठीक है, and you can just change the number of layers you have and experiment with this and let it train and then come back and tell you the accuracy. So it'll come back and create the accuracy. So you can actually, using this code, you can create any convolutional neural network which sequentially works. Yeah. Yes. Trained models है. Yes. बिल्कुल कोड भी पड़ा हुआ है. Yes. और ये है कि उसके ऊपर एक वो भी पड़ा हुआ है पूरा कि आप उसी वो मॉडल ट्रेन करके आपको देता है, आप ऑब्जेक्ट्स उसको दिखाए जाए and it will, I'll do it in the next class. So you don't even have to go through this. हाँ, वो आपको ऑब्जेक्ट डिटेक्ट करके आपको रियल ऑब्जेक्ट्स उसको कैमरे के आगे रखते जाएं, उसको बता दें इट इज दिस ऑब्जेक्ट, दिस ऑब्जेक्ट, दिस ऑब्जेक्ट. सो अब से आई वांट यू टू क्लासिफाई अमंग 10 ऑब्जेक्ट्स एंड देन जस्ट कीप शोइंग एन ऑब्जेक्ट, कीप टेलिंग इट इज दिस दिस दिस, फिजिकली उसको कैमरे के सामने रख के दिखाते जाएं उसको, और वो आपको नेटवर्क ट्रेन करके दे देगा. ओके, दैट नेटवर्क देन यू कैन टेक एंड just use it. So this is the model, and this is how it has performed. Okay, so these are I ask it to plot the activation. अगर इसको बड़ा करेंगे तो you will see के because वो reduce करता गया size, और उसने बहुत सारा plot करना था तो वो छोटी जगह पे किया हुआ है. But these are the images. If you look at this is perhaps 8, part of 8, because it is doing max pooling, this and that, so it is extracting all the features from the image.
Lowest layer में come.
कुछ भी नहीं रह गया, सिर्फ points रह गए. That's amazing कि उस पे तो features रह गए ना. The lower layer has only features, one value each, okay, and that is going to, so it is we'll learn about this in the next class. ये keras क्या है, TPU क्या है, models क्या हैं, but let me just show you one thing. ये वो model है, ठीक है. ये मॉडल था जी कि मैंने इसका ना इसी कोड में कर्नल का साइज 5x5 कर दिया. द सेम कोड, ओके, आई टुक द सेम कोड एंड आई चेंज द कर्नल साइज टू 5x5. सो हियर इज द इमेज, ये सारी इमेज है. एंड सो फर्स्ट आई हैव फर्स्ट कन्वोल्यूशनल लेयर हैज ये मैक्स पुलिंग, ये कर्नल है 5x5 का कर्नल है, ठीक है. दूसरा जो है मैक्स पुलिंग किया तो साइज हाफ हो गया. इधर फिर 5x5 का कर्नल लगाया, फिर मैक्स पुलिंग किया तो साइज इसका मैक्स पुलिंग से साइज ये साइज हाफ हो गया इसका, ठीक है. एंड बिकॉज आई एम नॉट डूइंग जीरो पैडिंग तो साइज 28 से 24 हुआ है. 24 से जब मैंने मैक्स पुलिंग किया तो 12 हुआ है. 12 से जब मैंने जीरो साइड वाले नहीं डाले हुए तो साइज इसका कम होता जाएगा 5 की वजह से. ये 8 हो गया और मैक्स पुलिंग किया 4x4 हो गया, और फिर इसको फ्लैटन कर दिया इनटू 128 लेयर्स. और यहाँ से 10 है नंबर्स, क्योंकि ये 0 हो सकता है, 1 हो सकता है, 2 हो सकता है, 9 हो सकता है. सो यहाँ पे जो नंबर होगा उधर मैक्सिमम वैल्यू आ जाएगी इसकी, ओके. और इसने इसको ट्रेन भी कराया है, ओके. सो दिस इज वेयर आई चेंज द कर्नल साइज टू 5x5. ये वो है, बाकी ये 2x2 है, ये 5x5 है, ये 2x2 है, और आखिर में सॉफ्ट मैक्स है. तो ये इसको जब मैंने चलाया आई गेट इवन एन एक्यूरेसी ऑफ 99.01. Previously it was 98 point something. So it has actually improved. The accuracy has improved by increasing the size of the kernel. So अब यही है कि you do a lot of experimentation to find out how good your algorithm is. तो आमतौर पे लोग जो करते हैं वो ये करते हैं ट्रांसफर लर्निंग करते हैं, यानी कि वो ये नेटवर्क कहीं से भी उठा लेते हैं, ये नेटवर्क कहीं से भी उठा लेते हैं, क्योंकि एवरी क्लासिफिकेशन इज डूइंग सम फीचर. और फीचर जब एक्सट्रैक्शन हो गई, नाउ यू मे हैव डिफरेंट नंबर ऑफ क्लासेस, ओके. तो इसको ट्रेन करा लेते हैं, एंड वंस दे आर ट्रेनिंग दिस दे कैन यूज एनी क्लासीफायर, मे बी SVM, मे बी नियरेस्ट KNN, ठीक है, मे बी न्यूरल नेटवर्क, लॉजिस्टिक रिग्रेशन, एनीथिंग. Once you are, and after you have the features, now it is up to you that what type of classifier you want to use. So here you have so number of models at your disposal to use. So you can train your own model. You can train some of the layers of this model, even in the transfer learning, or you can train all the layers of this model, which people would usually not do. ये सारे रेजनेट चलते हैं, हर एक कोई रेजनेट चला रहा है उसको लगा देता है. तो यू आंखें बंद करके, आजकल तो इतना आसान हो गया जो PhD की है, जो रिसर्च वगैरह है, बिकॉज सारे नेटवर्क बनाए हैं. यू जस्ट यूज अ नेटवर्क एंड 1D भी हैं ये सारे, ठीक है. सो यू कैन हैव अ 1D में 1D फिल्टर हो जाएंगे बस. सो दैट्स द ओनली डिफरेंस. विल सी सम 1D आर्किटेक्चर एज वेल. सो नेक्स्ट टाइम इंशाल्लाह वी विल कीप मूविंग एंड सी. ये मसला मैंने सेगमेंटेशन इसको की थी और रेजनेट यूज करके some other network, but interesting. So we'll come back to more applications of this, an interesting assignment where you train your own neural network hopefully.